All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump into it. This is Systems of Equations Word Problems, numero 10, number 10. And Matt and Ming are selling fruit for a school fundraiser. Fun times. Customers can buy small boxes of oranges and large boxes of oranges. Oh, how exciting! Matt sold 3 small boxes of oranges and 14 large boxes of oranges for a total of $203. Ming sold 11 small boxes and 11 large boxes for a total of $220. Find the cost of each of 1 small box of oranges and 1 large box of oranges. Huh. Okay. Lots of things with the color orange in them here. So I'm gonna do orange. Change this to red. And then we'll have our secondary be the orange. That way we'll have 2 equations that combine to orange. You're welcome. Okay, so Matt and Ming. Matt can be red and Ming can be yellow. So Matthew sold 3 small boxes of oranges, 14 large boxes of oranges for a total of $203. How do I turn that into a equation? Because that is the goal, is to turn these things into equations. So 3 small boxes, 3 small boxes of oranges. And I really don't like using the letter S as a variable because it looks like a 5. But you know what? The L is going to look like a 1. So I think I'll just use a cursive S here to try to compensate. So S, which does not look like a tiny 5, like the print would. So 3S, 3 small boxes, so 3's right here, small boxes of oranges, and means plus 14, and then the large boxes of oranges, so L, capital, or not capital, but lowercase l, large boxes of oranges for a total of. So for a total of is a phrase that you might see fairly often whenever they're talking about total. Means that you're adding them all up, and then it's equal to something. So when you're totaling something, you're adding a bunch of stuff up, and then it equals something else. So when we say for a total of, it's like, okay, we already did the add part. Now we equal it to what the total is. So equals, and then the last number, 203. There we go. Got our first equation. Now let's get the second one. So Ming sold 11 small boxes of oranges, 11 large boxes for a total of 220. Okay, let's break this down. 11 small boxes of oranges, so S, and means plus. 11 again, large boxes of oranges for a total of equals. Oh, that's a bad equal sign. Let's try that again. That's better. Okay. 220. So I'm noticing that in this equation, everything divides by 11. And I've said this before on previous videos on this topic and on other topics as well, but anytime you have equations and you're starting to set them up, it's good that you set them up exactly how they say to. However, once you get done setting them up, it is okay to reduce some of the numbers as long as all of the numbers can be reduced. In the red equation, that was not so, because 14 and 3 both don't divide by the same number, other than 1, of course. So I can't really reduce the red equation, but I can reduce the yellow equation because everything divides by 11. So if I divide everything by 11, then 11 over 11 would just be 1, so 1s, or just s. 11 over 11 is 1, again, so 1l, or just l. 22 divided by 11 is 2, so 220 divided by 11 is 20. Okie dokie. That's going to make our lives easier because now the numbers are smaller. Numbers are smaller equals Lives being easier. You're welcome. So now we decide whether we want to do elimination or substitution. I normally prefer elimination, so that is actually what I was planning on defaulting to. But you know what? Substitution is kind of warming up to me a little bit here. And I think substitution might be the better of the two. If you were to do like 1,000 of these problems, I think substitution would be the faster way to do it. A little bit more than half of the time. So we're going to go for that. And it also kind of helps to organize things a little bit, as we'll maybe see in a second here. So let's solve for, I don't know, it doesn't really matter. We'll get rid of the L, I guess. We'll take that L and make it go away. So S is equal to 20 minus L. Okie dokie. So we've kind of sort of solved for S, except, it's not just a number. It's equal to a number minus another letter that we haven't solved for yet. But now we can plug that in over here because there's S, which is equal to 20 minus L. And then the rest of the equation would be 3 right there. I'm not writing the S because I'm replacing S. I'm substituting S with 20 minus L, which is equivalent to S. Plus 14L equals 203. And now I can start solving. So I'm going to distribute that 3. That would be 60. Distribute it to the L. Minus 3L plus 14L equals 203. Okie doke, I can actually combine a little bit of like terms here. I've got two letters that are the same on the same side, so I can combine those. Minus 3 plus 14, same thing as 14 minus 3. 14 minus 3 is 11, positive 11, so plus 11L. Now I can subtract both sides by 60. Here we go. So now 11L is equal to 3 minus 0, 20 minus 6, and I have that. And I believe that goes in evenly. That looks like it goes in evenly. That looks like it would be 13 times. Looks like 13 times. Oh, sorry. I mean, it's going to equal 13, not that it's equal. There we go. Hold on. Getting ahead of myself here. Dividing both sides by 11. And then that, I believe, is 13. We could always times it. So 11 times 10 would be 110. Okay. And then 11 times 3 would be 33. So 33 plus 110 would be 143. Yeah, looks like that works. So L should be 13. And of course, if you're allowed to use a calculator, you can do that. But it is good to be able to do the math as well. So then I can plug in that L value and get the S value. So that's 13. S is equal to 20 minus that. And this is kind of nice because I don't really have to solve. With elimination method, you kind of have to solve twice. But with substitution method, part of the setup is that you solve for one of the variables already. It's just not equal to a number yet. So I don't know. It streamlines it a little bit. So S, let's switch to orange. So S is going to be equal to 20 minus 13, which is 7. Okay, so notice I only circled these. I almost always will box my final answers. I did not box them yet because I want to check to make sure that they both work. I just finished using the yellow equation. So I go back to the red equation, 3S, so 3, and I've already solved for S, plus 14, and then L, which I've already solved for that as well, equals 203. So this is how you check your work. You plug it into the equation you did not most recently use. So pretty much any one of the older equations, if you're dealing with 3 or 4 systems, but with just 2, it'd be whatever the other one is, the one you didn't just finish using, and that's the red one for us here. So now we do some math. 3 times 7 is 21, and this is also a very easy method to do to check your work to make sure you have the right answer if you're using a calculator, because it's much faster on the calculator. 13 times 14, 13 squared would be 169. So then you would add, see, 13 and 14. So I'd need to add another 13 to that. So 169 and 13 3, 6, 6, 1, so it'd be 7, 8, 1, 8, and then 13 to 9, 2, 1, 8, 2. Okay, let me double check on the calculator. My mental math is a little rusty today. 14, 13. Yeah, 182. Okay. Just seems a little off today. 21 and 182. 1 and 2 would make 3. 2 and 8 would make 10. Carry a 1. And looky there. It works. Big old check mark. So these are, in fact, the answers. And I've said this before. I'll say it a million times. You don't have to solve, you don't have to do the thing we just finished doing. You don't have to, right? You could just settle for the answers you got. However, the amount of extra work is very minimal compared to the amount of extra confidence you get in your answer. The likelihood of getting this question wrong after checking it using this little extra 2 steps or whatever is like way higher. The likelihood of messing something up, because you could mess something up in so many different ways and get different answers, and you wouldn't know unless you checked it. There's so many ways to mess these up because there's so many steps. So it's really, really, really worth it. It's out of all the different ways to check answers and all the different math topics there are, this one is one of the best because it's only a very, very minimal extra effort to check your work, and you get way more confidence in your answer. So highly, highly worth it, especially on our quiz or test. And that's my 2 cents for the day, and that's the question of the day. So I hope it was helpful. And, of course, if you find it helpful, you can always like and subscribe and all that good stuff. And go check out my website. It's in the description below, myersmathematics.com. I've got all kinds of extra stuff over there as well, like my guide, The 5 Math Mistakes Everyone Makes and How to Avoid Them. Go check that out, myersmathematics.com. Link in the description below. Catch y'all in the next episode real soon. Blessings, y'all.